Welcome back. Mental models done. Now we get our hands dirty. In this lesson, we install Fail2ban with apt, watch the default sshd jail come up on its own, then deliberately fail SSH logins until we ban ourselves. Read the ban in fail2ban.log and unban. 4 beats. Install and verify, meet the default jail, write your first override, and trigger a real ban. Real commands, real bans. If something breaks, that's the lesson. Step 1. Install. One apt command pulls in fail2ban along with py-notify for log watching, the system bindings, and whois for IP lookups. That's your whole dependency tree. Notice the symlink into multiuser.target.wants. That's systemd wiring it up to start on every boot. And when you run systemctl status, it's already active, already running, PID assigned, but meaning the daemon is reading auth.log right now. No config file touched. On Debian and Ubuntu, the sshd jail is on by default, so SSH is protected the moment apt finishes. So where did all that actually land? 6 locations worth knowing by heart. The 2 binaries in usr bin, client you'll talk to constantly, server you leave alone, that's system's job. Under etc. fail2ban, you've got jail.conf and the filter.d directory full of regex patterns for sshd, Apache, postfix, and friends. Read them, don't edit them, since upgrades will wipe your changes. The system unit lives in lib or systemd r system, and every ban gets written to var log.fail2ban.log, which you'll be tailing a lot. And notice what's missing. Jail.local. The package deliberately doesn't create it. That's our file, and we'll build it in step 3. And here's the part nobody tells you. On Debian and Ubuntu, the sshd jail is already armed. No jail, local, no edits, no restart. Apt finished, and the daemon started watching. Ask it yourself. Fail2ban client status shows 1 jail, sshd ready. Drill into it and you'll see the filter is already tailing var log auth.log with counters at 0. 0 bans, sure. But only because nobody's failed a login yet. Expose port 22 to the internet and that number starts climbing within minutes. But active doesn't mean working. So we run 4 checks, and if anyone fails, you stop and fix it before moving on. First, ping the daemon. It should reply pong, proving the socket in var run fail2ban is alive. Second, confirm the sshd jail actually found auth.log. An empty file list usually means you're on rhel, where it's var log secure. Third, tail fail2ban.log and look for jail sshd started. And fourth, the only one that really proves it works, manually ban a testnet address. If that returns 1, you have a working firewall. Now that you've proven Fail2ban works, here's the rule that saves you from heartbreak 6 months from now. Never edit jail.conf. The package owns that file, and the next apt upgrade will wipe your changes without a word. Instead, create jail.local right next to it. Same directory, same syntax, and put only your overrides there. Everything else inherits from jail.conf automatically. Read the original as documentation, then close it and do your real work in the .local file. So let's write that local file right now, and we're keeping it deliberately tiny. 3 overrides in default. Ban time and find time both at 10 minutes so our experiments don't punish us all afternoon, and max retry drop to 3 because 5 is too generous for SSH. The SSHD block just makes the default explicit. Then, and this matters, reload, don't restart. Restart drops every active ban, reload picks up your config without breaking a thing. Now the moment of truth, and you have to do this from a second machine, not the server you're SSH'd into. Your laptop, your phone, hotspot, another VM, whatever. SSH in with a deliberately wrong password 3 times. On the 4th attempt, watch closely. You won't get permission denied anymore. You'll get connection refused. The TCP handshake itself is dropped. That's Fail2ban telling iptables to reject every packet from your IP. You just saw exactly what a bot sees right before it gives up. Before you trigger that ban, set up your viewing booth. On the server, open 2 terminals and tail both log files side by side, auth.log on the left, fail2ban.log on the right. The left side is sshd narrating what the attacker did. 3 failed passwords for user nobody from your laptop's IP. The right side is Fail2ban's reasoning. Found, then notice. Ban. Same 3 seconds, 2 perspectives. Cause on the left, effect on the right. And here's the slide you'll want to bookmark, because sooner or later you will ban your own IP. Most of us do it twice. 3 ways back in, ordered by how painless they are. If you've still got any working shell on the box, Fail2ban client set sshd unbanip is instant and clean. Option 2 is just patience. 10 minutes on our test config, but if you've already pushed ban time to 24 hours in production, patience won't cut it. Option 3 is the rescue console. Log in through your provider's web console, list the F2B sshd chain, and delete the reject rule by hand. And the real fix. Add your own IP to ignore IP in jail.local. We'll do it properly in Lesson 10. So let's take stock. 6 skills. And if you actually typed your way through this lesson instead of just watching, all 6 should feel like muscle memory by now. Install it, confirm the sshd jail is live, drop a clean jail, local with your 3 tuning knobs, trigger a real ban from a second box, read auth, log, and fail2ban.log side by side, and get yourself unbanned 3 different ways. If any one of those felt shaky reading it just now, that's your signal. Scroll back, spin the VM up again, and retype it. The keyboard is where this sticks. And that's Lesson 02 in the bag. Package installed, sshd jail running, jail.local on disk, and you've banned and unbanned yourself. Fail2ban isn't theory on your VM anymore, it's working. Next up, we go 1 layer deeper, how log scanning actually works under the hood. In notify versus polling, what breaks when logs rotate, and how to flip on debug mode to watch every single line your filter tests. Keep the VM running. See you in Lesson 03.